So there are situations where we want to be a little bit more precise than our intuition that we normally work with. And so we're going to take that intuition, we're going to formalize it, and make it into a more structured process that we can now use data to make decisions with. So step one. Step one of hypothesis test. What should step one be for hypothesis testing? Okay. I see the answer I immediately got in my 1 o'clock section was is test a hypothesis. That's jumping the gun a little bit. So we have to formulate hypotheses. Okay. So what is a hypothesis? Educated guess? I wouldn't always say educated.
An expectation about how you believe something will function based on previous observations.
Okay. Essentially a guess. Although I would say that maybe that's a little bit more than a guess put into it. But certainly hypotheses don't have to be intuition. They don't have to be simple. I've worked with a lot of situations where just formulating this hypothesis is a tremendous amount of effort. And it may be a great deal involved in it. In fact, it may be that the hypothesis that you're currently working with was formulated by a series of 2 or 3 years of evaluating and testing hypotheses that have brought us to this point where we now have this hypothesis we're working on today. So it may not be simply an educated guess as we would normally think of an educated guess. The educated part may be an extreme amount of work going into it. So it can be a lot of things involved. So we're going to formulate hypotheses. We're going to formulate these as 2 formal hypotheses. What we're going to call a null and alternative hypothesis. This null hypothesis is essentially a nothing going on type condition. Status quo, maybe current condition of things. And we're going to find that it always has an equals in it. Somewhere, somehow, there is always an equals condition involved in it.
I'm sorry, just sort of bugged me a little. Can you put an S on the end of always?
Sure. So this is always going to have an equals condition. Okay? If you're formulating a hypothesis, if you're coming up with a null hypothesis, and your null hypothesis does not have an equals condition, then there's a problem. And as I'm reading things, as I'm grading homework, grading tests, when I'm looking at them, I'm looking for that equals condition to show up. Okay? If I can't see the equals condition in the null hypothesis, that's a problem. So the 2 things we're looking for is an equals condition, and we also said we're looking at a population parameter. So it's an equals condition about the population parameter. The alternative is what we would like to prove. Okay? In general, you will see these as a less than, a greater than, or a not equals. What you will not see in an alternative hypothesis is an equals condition. The alternative may not be the mean is equal to 5 or mean A is equal to mean B. Those cannot be alternative hypotheses. Those are null hypotheses type statements. Okay? So the alternative is the thing that we would like to prove, and in general has a less than, greater than, or not equals condition.
So every hypothesis contains both of those characteristics then? Or are those 2 different?
Whenever we formulate hypotheses for a hypothesis test, there will always be a pair. And the pair will consist of a null and alternative. In essence, this is a current state of the world. This is the other condition. If we can reject this, then this must be true. Okay?
Can you give us an example of a null alternative hypothesis?
A null hypothesis might be that the average height of Grand Valley students is 6'8" The alternative would be that the average height of Grand Valley students is greater than 6 foot inches. So that would be a null and alternative hypothesis. And we'll have a number of examples when we get down here in problem number 11, chapter 12, where we're going to look at null and alternative hypotheses for a number of different statements. So we'll have some more practice at that. But we formulate hypotheses. So this is already a little bit more than what you find yourself doing in everyday life. At least I don't usually find myself formulating hypotheses in this form. Not consciously anymore. Step number 2. Oh, before we go any farther, another way to think of this, in your book I think talks about this. If you think of this in terms of a jury trial or our court systems, the null hypothesis is the condition of being innocent, and the alternative is the guilty condition. And so just like in the court systems, or at least the court systems we have here, well, ideally the court systems we have here in the U.S., you are innocent until proven guilty. Sometimes I get a little cynical. There are some situations where I've dealt with where you're guilty until proven innocent. But in general, our court systems are set up where you are innocent until proven guilty. The same thing will be true here. The null hypothesis is accepted until we can prove with a preponderance of evidence that the alternative must be true. Okay? So what we're doing is we're looking for evidence for the alternative. And we would like to prove that alternative. What we'll find is that the alternative can be proven by a hypothesis test, but null can never actually be proven. We can simply fail to reject the null hypothesis. Okay? Step number 2. The next step is one that we don't often do in real life. But it's a necessary step when we start to get more formal and we start to get more precise. And that is to verify conditions. Again, each time we look at a particular situation, there will be a different set of conditions that are necessary to verify. But what we're doing is we're essentially verifying that the sampling distribution of the test statistic is sufficiently close to a true normal or a true t or whatever we're working with for us to be able to trust the outcome of our test. If it's not sufficiently close, then we have to question whether our results are valid or not. Okay, so we want to verify that the conditions are adequate before we continue on. And in each case, in most cases, it will be primarily a question of whether the sample is sufficiently large to give us good information. Remember we talked about our sampling distributions. Our sampling distributions for 5 and 25 rectangles kind of acted like we wanted to, but they didn't have a good normal distribution to them. Those samples are in general too small for doing inferences. We'll find where that breakpoint is, and usually they're just a rule of thumb that we're going to work with. But we'll find out what conditions are appropriate to be able to say that the sampling distribution acts close enough to what we need for us to be able to come up with decent measurements of whether something is strong evidence for the alternative or not. Okay? As I'm going through these steps are in your textbook. The steps in the textbook, there are 5 steps in the textbook, just like I have, but my steps are a little bit different than the text steps. I've slightly reorganized and mostly broken them up differently because I want to emphasize different things. And if you happen to write something down and use the textbook's steps instead of my steps, I won't count that wrong. I just happen to think that my way of looking at it is a little bit clearer and emphasizes things a little bit better. But the one thing I will insist is that you use the steps. The reason is that the steps are there to help you not forget to do things. What I find is invariably, if people skip working through these steps, they want to jump right to the conclusion. Invariably, they're jumping to the wrong conclusion because they've forgotten something. They'll have forgotten to verify conditions. Sometimes they'll have forgotten to calculate test statistics properly. So get used to doing the steps. Step number 3 is we're going to assume the null hypothesis. So this is the standard that we normally would do when we are making our observations, learning about things. We're assuming that our expectations are correct, that our expectations are true. Okay? So we're assuming the null hypothesis.